Hello, everybody. Good morning. For my senior project for operating systems, I chose to do the process scheduler. And so I'm going to be going through the commands showing you that they work. Let's start out with priority. With the priority scheduler, as you can see here, it does it by priority first, and then it does it by the TID, the task identification number. So right here you can see I made it so the lowest value numerically is highest priority. So the 1 will go first and then the 3, etc., etc. So yep, you have them all going in the correct order here, 1 through 10. And then if you look and see the ones that have the same numbers, it is correctly then sorted by the TID 1, 2, 6, and 3, 4, respectively. And as you can also see by priority, it does not look at the units. It's simply by priority and then the TID. And the next one I'll be showing you is first come, first served. State. So this is purely TID. As you can see here, 0, 1, 2, 3, 4, 5, 6, 7. So it does it in the correct order there. Next up, we have shortest job first algorithm. And how this works is it will go with the one with the smallest estimated burst, but it's not an estimate. We have actual variables for this project for demonstration purposes. And these units here are the burst, and the burst is a CPU time of execution it gives it before it pulls it off to put something else on instead. And so we see it goes completely finishes out this. The one that has TID of 5 has the lowest burst, so it does that one to completion. Then it goes to the 15, and then as you see here, whenever it's got 2 with the same burst, it goes by TID. 0 represents got there first, so that's the correct order. And then we have 3 25s, TID 1, 2, 7 respectively. So it does that in the right order as well. And then we also have the round robin, which is actually one of my favorites, which is basically going back and forth for a certain amount of time until all of the processes have been served and have no more bursts left to complete. And it's a little more complicated, so I'll show you how it works. Go back up to the top. I added in a little prompt show when things finish. So first off, it starts with the TID. So this one came first, so it goes first. Has 20 bursts right here, and 10 of those are done right now. And then it goes to 1, where it starts at 25, and then with the burst, and it uses 10 of those. And you can see it keeps going in that pattern because all of these have very high burst. As you can see, all are 10 or greater. But if you go right here, we have 0, and then 1, 2, 3, 4, 5, 6, 7. And so once we go in that order, 0 through 7, we go back to 0. All right. But this time you'll notice that it has a burst of 10. So it took away from the first time, kept the changes, how much burst it used. And so this time it goes through, it completes. And that means from now on, we won't have to worry about the process with TID 0. It's done now. It's completed. So we keep going this order until they're all completed. And another thing to note is if it happens to have less than the quantum of 10 units, like this right here, it will just run out the remainder of them and then complete and give up the CPU for another processor immediately, a little early. But that's all I have. I unfortunately was not able to figure out priority round robin in time. But I hope you like what I do have, and thank you for watching my senior project presentation.